Hello, in this video we are going to go over the solution of the problem 64, minimum pass sum. In this problem we are given a m by m grid filled with non-negative numbers, and we are supposed to find a path from top left corner to the bottom right corner which minimizes the sum of all numbers along its path. Imagine that we have a grid like this, so it's a m by n grid, and we are supposed to start from top left corner and finish at bottom right corner, and we can have two movements to the right or down. So one possible solution could be this: I can move from 1 to 1, 1 to 5, 5 to 2, and 2 to 1. So if I take this path, so the summation is 1, 2, 7, 9, 10. So this path is 10. But we are looking for the path with minimum sum. So the path that is our answer is actually this one. So we can move here, here, down, down. So it's going to be 1 plus 3, 4, 5, 6, 7. So if I take the green path, so I get 7, and that is our answer. We are going to solve this problem using dynamic programming, and we are going to use the bottom-up approach. And for doing that, we are going to consider a sub-problem. For example, if I start at this cell, so what is the path sum? So I have a value 2. I'm going to move to the right cell, and there I have value 1. So the path sum for this cell is 3. How about this cell? So I have a value 4, and on the right side I have a sum of 3. We know that the path sum for the right cell is 3, so I say 4 plus 3, this is 7. So far I'm following a formula like this. I'm just saying dp of RC at the point RC equals the value of the grid at that point. So grid at RC plus the value of the dp on the one column on the right side. dp of same row, one column forward. Okay, so this was the formula we used to fill out these two cells. Now let's consider this cell. So for this cell, I know the value is 1. Okay, and I know that I can move down, and down I have a value 1, so it's 1, so it's going to be 2. Now let's consider this cell. So for this one, I know the value is 1, and if I go one cell down, I know already I calculated 2 in my dp, so I say plus 2 equals 3. So technically now I'm adding my grid value to the dp1 row below. So I'm doing this. I say grid RC plus dp of R plus 1 C. So I use this one for the last row and this one for the last column. Now let's consider this cell. So for this cell, value is 5 plus, now I have two options. I can use from this cell, from the right side, or from down. So which one should I select? If I select from the right side, I get the value 2, and if I use the down, I get the value 3. So we are looking for the path with minimum sum. So I'm gonna consider the minimum of these two. Okay, so for example here the minimum 3 and 2 is 2. So 5 plus 2 equals 7. Okay, let me rearrange this formula. Okay, now we have our formula. Let's continue for the other cells. For example, for this cell, the value is 1. From the right side, I get 7. From down, I get 7. The minimum is 7. So 1 plus 7 equals 8. Now let's consider this cell. So value is 3. Plus, from the right side I get 3, from down 7, so the minimum is 3. 3 plus 3 is 6 here. And for the last cell we have value 1 plus from the right side I get 6, from down 8, so minimum is 6. 1 plus 6 is 7. And the value of the last cell, 7, is the output of our algorithm. Okay, now we have the formula and we can fill out the cells. And also we saw that, for example, for the last row, I only have a cell on the right side. We don't have anything down. And if you want to use this formula for entire of the DP and calculate all of the elements in a one for loop, so we should pad this DP matrix, and we are gonna do this. So I'm gonna pad that here, and let's see what values we should put. For example, when we calculated this value 7 here, so for calculating that, so we looked at the element on the right side, but for the down, what could be an element that when I calculate the minimum always gives me the value on the right side? So I just need a very big number here. So for example, positive infinity here. So now I have for this cell from the right side 3, from down positive infinity, so minimum is always 3, so I put 3. In a similar fashion, for this one is also positive infinity, because from the right side I have 1, from the down I have infinity, I get 1 here. Okay. Also for example, for this cell, for the top right corner, for value 3, so I only had value from down, but from the right side I just need a big number, so I can put positive infinity here, and also for the cell below that. Now let's consider this cell. So for this one, we know the value is 1, and that is what we used in our DP. So if this one is positive infinity and this one is positive infinity, so the minimum of two positive infinities will be positive infinity, and it's going to be a problem because then 1 plus infinity is infinity, and then the whole DP will be infinity. So we don't want that happens. So what we are going to do is that we are going to intentionally make one of them 0. So we could, for example, put this padding here 0. So in that case, minimum of 0 and positive infinity is 0. So we just add 1 plus 0. That's going to give us 1. So that is going to be correct. Or we could do this. We could put this one as 0 and this one as positive infinity. And also this cell, for padding, it doesn't matter. You can leave it as positive infinity or anything else. Okay, now we have our formula and our padding. Let's start writing the code. We have a function called minimum pass sum, and the input is grid. So number of rows and number of columns are length of grid and length of one of the rows, for example, the first row of grid. And then I'm going to initialize our DP. So we say DP equals, and we are going to initialize that with infinity values. So I'm gonna say float infinity for I in range of number of columns plus 1, because we want have the padding as well. And then this array for j in range of number of rows plus 1. Okay, now we define our DP and all of the values are positive infinity. And as we said, we are going to change one of the values of the padding to 0. I mean this one. Let's make that 0. So we say DP of last row and one column before the last one. So we are going to say the value is 0. Now we initialize our DP, and the next thing that we're going to do is to follow our formula and fill out all of the cells. So we say for R in range of R minus 1 to minus 1 in reverse order, and for C in range of C minus 1 minus 1 minus 1. And now we could say DP R C equals, now I should use our formula. So our formula is this one. grid plus minimum of the two cells, one on the right, one on the bottom. Okay, so we say grid R C plus minimum of DPR, one column forward, and DP of one row below, same column, and at the end we are going to return DP 0 0. Okay, let's run it, and we see the output is 7, and that is what we expect to see for this grid. Okay, now let's talk about time and space complexities. The time complexity is big O of n, where n is the multiplication R plus 1 times number of columns plus 1. And we can ignore the 1, so it's basically R times C, or size of the cells in our grid. And our space complexity is also order of n, because we need n spots in our DP to record the values. Okay, this is the solution of the problem 64, and thank you so much again for watching this video.